June 6, 1944. Omaha Beach. You've seen the movies, the ramps dropping soldiers pouring onto sand under machine gun fire. But here's what Hollywood never shows you. The waiting, thousands of men crammed into steel boxes circling offshore for hours vomiting from seasickness, watching the clock tick, while German gunners zeroed in on predictable patterns. That nightmare, it wasn't supposed to happen, and it only didn't become a complete catastrophe because one stubborn boat builder from New Orleans had solved a problem the entire U.S. military said was unsolvable. Let's rewind to 1941. The American military is staring at a terrifying math problem. They need to land 150,000 troops on hostile beaches defended by the most fortified coastline in human history. Current landing methods. Absolute disasters. The British learned this the hard way at Gallipoli in 1915. Troops rowing ashore in wooden boats slaughtered before they touched sand. By World War II, most navies use the same basic approach. Large ships anchor offshore, lower smaller boats on debits. Those boats row or motor to the beach. Troops climb over the sides into chest of water while carrying 60-pound packs. The problems multiply like rabbits. First, the physics. A soldier climbing over a gunwale while waves smash the boat into shore has maybe a 40% chance of not breaking an ankle. Second, the exposure. You're a sitting duck for 30 seconds, silhouetted against the sky. Third, the speed. Unloading one company, roughly 120 men, took anywhere from 45 minutes to 2 hours depending on surf conditions. Fourth, and this is the killer, you can't bring vehicles, jeeps, artillery tanks, the weapons that actually win battles. They stay on the ship because there's no way to drive them off a boat into 3 feet of water. The British had one solution: specialized landing ships with bow doors, but these were massive vessels that had to beach themselves. Once grounded, they were stuck for hours. Vulnerable and mobile targets. The Japanese experimented with their Daihatsu-class landing craft, but these still required troops to jump over the sides. Every navy in the world was trying to solve the same problem. How do you turn a boat into a bridge? Now here is where it gets interesting. In September 1941, the U.S. Marine Corps posted a technical requirement that read like science fiction. They wanted a boat that could carry 36 combat-loaded troops, hit a beach at full speed, drop those troops onto dry sand in under 10 seconds, then reverse off the beach and return for another load, all in under 15 minutes round trip. The kicker, it needed a draft shallow enough to clear coral reefs, but stable enough to survive open ocean crossings. Oh, and one more thing, it needed to be cheap enough to build by the thousands and simple enough that 19-year-old coxswains could pilot them under fire. Every major shipyard in America looked at those specs and said the same thing. Impossible. The hull shapes needed for shallow draft and ocean stability contradict each other. A bow ramp strong enough to support running troops would be too heavy. The hydraulics would fail in salt water. The list of objections filled 3-ring binders. But there was this one guy down in Louisiana who kept showing up at Navy procurement offices with a wooden model and a grin, insisting he had already built the thing. They thought he was out of his mind. Turns out he was just from New Orleans. Andrew Jackson Higgins was exactly the kind of person military bureaucrats hate. Self-taught, loudmouthed, didn't own a suit that fit properly, and had the annoying habit of being right when everyone with a college degree said he was wrong. Born in Nebraska in 1886, he spent 30 years building shallow draft boats for oil prospectors, trappers, and rum runners working the Louisiana bayous. While Naval Academy graduates were designing sleek destroyers, Higgins was figuring out how to float a half-ton of engine through swamp water, 18 inches deep, without getting stuck on a cypress knee. His company, Higgins Industries, wasn't even on the military radar until 1938. The Marine Corps had been testing various landing craft designs for years, all failures. They watched these boats run aground, 50 yards from shore, or flip sideways in the surf, or get their propellers chewed up on sandbars. Then some junior officer remembered hearing about this crazy guy who built boats that could run on heavy dew. As the saying went, the Marines sent observers to New Orleans mostly to check a box. Higgins loaded them into his latest swamp boat called the Eureka and drove it full speed onto a mudflat, spun it around like a sports car, and motored back into deep water. The observers cabled Washington. You need to see this immediately. Here is what made Higgins' design revolutionary and why the established shipbuilders hated it. He threw out every rule. Standard naval architecture said, a boat's bow should be sharp to cut through water efficiently. Higgins built a bow shaped like a snow shovel, flat wide and angled upward. Traditional wisdom said you needed a deep keel for stability. His boats had almost no keel at all, just a shallow semi-tunnel protecting the propeller. The whole shape looked wrong and felt wrong to anyone trained in conventional marine engineering, but in Louisiana swamps, it worked like magic. The military's initial response was contempt mixed with suspicion. Bureau of Ships engineers produced long technical papers explaining why the Eureka's design broke fundamental hydrodynamic principles. They argued the flat bow would create too much drag, the shallow draft would make it uncontrollable in currents, and the protected propeller tunnel would cause cavitation problems. Higgins invited them to New Orleans for demonstrations. They declined, citing budget constraints. Translation: we're not wasting government money on swamp boat nonsense when serious shipyards were developing proper landing craft. But the Marines kept pushing because they were the ones who would actually have to storm beaches. And they understood something the desk admirals did not. In April 1941, the Navy finally agreed to competitive trials in Norfolk, Virginia. 4 shipyards presented their designs. 3 were from established maritime companies with solid reputations. Higgins showed up with 3 boats strapped to a barge. No blueprints, just hardware. The official evaluation criteria included seaworthiness, speed, maneuverability, durability, and here was the big one, ability to get itself off of a beach. The results were not close. Higgins' boats hit the beach at 9 knots, rode up onto sand, backed off in under 30 seconds, and did it again and again, 20 times without fouling the propeller or damaging the hull. The competition. One boat buried its bow and would not move. Another's propeller shattered on the first grounding. The third made it on and off once, then started taking on water. By day 2, Navy observers were quietly rewriting procurement protocols. By day 3, Higgins had a contract for 1,500 boats, and he still had not shown them his actually crazy idea yet. The Eureka boat solved half the problem, getting to the beach and off again. But troops still had to climb over the sides, and there was no way to drive a jeep out of it. Higgins knew this. He had been sketching solutions on the margins of napkins for 2 years. But every design ran into the same problem. Physics say ramp at the bow means you need hinges, and hinges mean a weak point. Where the boat bends, the forces are huge. Imagine a steel plate 4 feet wide, 8 feet long, holding up 6 men weighing 250 pounds each with full gear, while the boat pitches in 3-foot waves. That is 1,500 pounds bouncing on a hinge every 2 seconds. Engineers calculated the stress would snap any hinge in a week of saltwater operations. Then in late 1941, a Marine Corps officer named Victor Cruac showed Higgins a photograph that changed everything. Cruac had been an observer in Shanghai in 1937 watching the Japanese attack Chinese positions along the Yangtze River. The photo showed a Japanese Daihatsu landing craft with a ramp at the bow, not over the sides, a ramp. Higgins stared at the picture for maybe 10 seconds, then allegedly said something unprintable about how the Japanese had the right idea, but the wrong execution, because their ramp still made troops wade through ankle-deep water. Here, Higgins' swamp boat experience kicked into overdrive. The Japanese design dropped a ramp that angled down into the water. Fine for calm rivers, useless for surf zones, where every wave changes the depth by 2 feet. Higgins realized the ramp could not just drop. It had to drop, and Higgins had to extend the whole ramp forward, creating a bridge from the boat deck to dry beach. The geometry sounds simple until you actually build it. The ramp needs to be the same angle as the bow, which is 45 degrees in his design. When raised, it becomes the bow itself, a watertight continuation of the hull. When lowered, it has to lock flat and stable enough that a 5,000-pound Jeep can drive across its speed without bending more than half an inch. His solution was pure mechanical brute force, 2 hydraulic cylinders pulling against steel cables backed up by manual chains in case the hydraulics failed. The ramp itself was 1/4-inch steel plate reinforced with I-beams welded underneath. Heavy as hell, but that weight actually helped. Once it slapped down on sand, momentum and mass kept it planted. The hinges were not delicate pivot points. They were massive pin assemblies 4 inches in diameter, the kind you would use on a drawbridge. Could they fail? Absolutely, but they would survive long enough to matter. Higgins designed the whole mechanism so a crew could replace a broken hinge in 20 minutes with a sledgehammer in a cheater bar. The first prototype was ready in May 1942. Higgins called it the LCVP, LCVP landing craft vehicle personnel. The military called it the Higgins boat, though Andrew hated that name because he wanted credit to go to his engineers. The Marine Corps brought it to Solomon's Island, Maryland for testing. The team loaded it with a full platoon, plus a Jeep, something no landing craft in the Higgins boat, motored to a beach, and they watched the ramp went down. The Jeep drove off in 4 seconds. Troops got off in another 6. Ramp went up, they reversed into deep water. 13 seconds total from grounding to withdrawal. The officer running the test radioed back to Washington. Specifications met. Recommend immediate mass production. 3 weeks later, Higgins had a contract for 10,000 units. The Pentagon still thought the design would fail in combat, but they were desperate enough to take the risk. Dwight D. Eisenhower said it years after the war, and the quote deserves to be carved in marble somewhere. Andrew Higgins is the man who won the war for us. If Higgins had not designed and built those landing crafts, we never could have landed over an open beach. The whole strategy of the war would have been different, coming from a 5-star general who commanded the largest amphibious invasion in human history. That is not an exaggeration. It is a confession, but let's look at the actual numbers, because the reality is somehow more unbelievable than the legend. Guadalcanal, August 7, 1942. First major test of the Higgins boat under combat conditions. The 1st Marine Division needed to land 11,000 troops on beaches defended by 2,800 Japanese soldiers who had months to prepare pre-war doctrine, said this operation would take 14 to 18 hours to get everyone ashore with equipment. The actual timeline was 4 hours and 17 minutes from the first boat hitting sand to the last rifle company digging in marine logistics. Officers thought their stopwatches were broken. They radioed the transports offshore, confirmed troop counts. This can't be right, the transports are confirmed. Every man accounted for plus 73 vehicles that doctrine said could not be landed on day. Here is the mechanical magic that made it possible. A single Higgins boat could go from the beach to the transport and back in 11 to 15 minutes, depending on distance. That includes grounding, unloading, reversing motoring, back and reloading. And compare that to British landing craft at DP 3 weeks later, which averaged 32 minutes per cycle, and could not get themselves off the beach, leaving dozens stranded as the tide went out. At Guadalcanal, the Marines had 87 Higgins boats in the first wave. Simple math, 87 boats times 4 trips per hour equals 348 boatloads delivered every 60 minutes. Each boat carried 36 men or 1 vehicle with crew. Do the math and you get over 12,000 personnel, equivalent movements per hour. The bottleneck was not the boats, it was how fast you could load them on the ship. Tarawa, November 1943. This is where the 3-minute claim gets tested under nightmare conditions. The Navy's hydrographic charts were wrong. The tide was 18 inches lower than predicted, and a coral reef extended 500 yards from shore. Larger landing ships ran aground and could not move, but the Higgins boats, drawing only 3 feet of draft, skimmed right over the reef like it was not there, wave after wave every 3 to 4 minutes. Another boat hit Red Beach. The Japanese defenders had machine guns and mortars on the waterline, expecting slow-moving targets. Instead, they got a conveyor belt. Marines took terrible casualties, over 1,000 dead in 76 hours. But they kept coming because the boats kept running. Japanese commander Kishibasaki had boasted it would take 1,000,000 men, 100 years to conquer Tarawa. The Marines did it in 3 days, mostly because Higgins boats delivered reinforcements faster than defenders could kill attackers. Sicily, July 1943. Operation Husky involved 2,590 landing craft of all types hitting 26 beaches at the same time. Higgins boats made up about 1,400 of that total. The operation was precise. Boats grounded, unloaded, withdrew, and returned with such rhythm that beach masters were spacing arrivals like air traffic controllers. Some boats made 14 round trips in the first 12 hours. Crews worked past exhaustion, steering by instinct, loading by muscle memory. When Navy analysts looked at after-action reports, they found the average Higgins boat at Sicily delivered 468 troops, or 23 vehicles over 3 days of continuous operation. Multiply that across 1,400 boats, and you can see why the Germans could not reinforce fast enough to fight back. Then came Normandy. June 6, 1944. Over 1,500 Higgins boats in the first assault waves at 5 beaches. Utah Beach had boats arriving every 3.2 minutes at peak hours. Omaha was chaos. German defenses were much stronger than intelligence predicted, But even there, the boats never stopped coming. That is what broke the German defense. Not heroism alone, but sheer numbers. You can kill the first wave, even the second, but the eighth wave, the 15th. The boats made that persistence possible. The Japanese had the photograph. They had seen their own Daihatsu landing craft, which had the bow ramp idea back in the 1930s. So why did they not build something as effective as the Higgins boat? This question puzzled Allied intelligence officers during the Pacific Campaign, because every time U.S. forces captured a Japanese-held island, they found landing craft that almost worked but failed in important ways. The answer shows something interesting about how engineering ideas shape wars. The Daihatsu-class landing craft, first used in 1937 during the Second Sino-Japanese War, looks similar to the Higgins design. Bow ramp, shallow draft, could beach and pull back. But Japanese engineers had built theirs for different conditions. Their main operations were on rivers and calm coastal waters in China and Southeast Asia, places where you could predict tides, check beaches in advance, and work in protected waters. The Daihatsu had a deeper V hull for speed in calm water, which made it fast in ideal conditions, but really bad in surf. When waves hit the V hull at an angle, the boat could skew sideways, sometimes even flip. The ramp mechanism shows the Japanese designers used a lightweight ramp that dropped into the water at a steep angle. It was fine for a riverbank with 6 inches of water, but on a beach with 2-foot surf troops still had to wade through knee-deep water, losing speed, losing surprise, and getting shot. The Marines reported capturing Daihatsu craft at Guadalcanal and testing them. Their assessment was harsh. Ramp does not extend hull line. Vehicle operations impossible in surf extraction from beach, inconsistent because engines were weak and hull design was bad. Here is the bigger mistake. The Japanese never understood that Higgins's ugly, blunt bow was not a compromise. It was the main idea. That snow shovel shape let the boat ride up onto the beach at speed, using momentum to climb the sand until the ramp could drop onto dry ground. The Daihatsu's sharper bow would dig into sand and get stuck. Japanese crews tried to compensate by approaching slower, which gave defenders more time to aim. At Tarawa, U.S. forces found abandoned Daihatsu craft that had landed successfully, but could not reverse off. The propellers hit coral or the hull sank too deep. They became stationary bunkers instead of transport. The Imperial Navy tried to copy Higgins' boats. In 1944, Japanese engineers studied captured LCVPs from the Philippines and made plans for a domestic version. But by then, Japan's industry was collapsing. They had the blueprints, but did not have the factories to make complex hydraulic systems in large numbers. More importantly, they did not have enough shipyard workers. Higgins Industries used semi-skilled laborers who learned to weld hull sections in weeks. Japan's shipbuilding culture relied on master craftsmen, which does not work when you need thousands of boats fast. There is a captured Japanese naval report from late 1944 that is almost sad to read. The author and engineering officer wrote that American landing craft showed crude but effective design principles that traded elegance for mass production and rough water performance. He noted U.S. boats could be operated by inexperienced crews because the controls were simple and the hull forgave mistakes. Japanese landing craft required skilled coxswains to handle properly. In his conclusion, the officer wrote that Japan focused on quality while the Americans knew the war would be won by quantity, and that difference could not be fixed just by copying a boat. By 1945, Japanese forces in the Pacific were still using Daihatsu craft that made troops jump into water. Every U.S. amphibious assault had become a perfect example of mechanized efficiency, but the Japanese had invented the bow ramp and never realized its full potential. Higgins took their idea, understood what it should do, and rebuilt it from the ground up. That is not just copying, that is evolution. August 7, 1942. Guadalcanal was about to hit Japanese machine guns and coral with chaos that makes engineering textbooks look easy. The Higgins boat had done beautifully in calm water tests at Norfolk and Solomon's Island, but those were controlled environments with measured beaches and no one shooting back. Now 87 boats were heading toward Lunga Point, carrying the 1st Marine Division, and nobody knew if the design would survive the actual combat. First problem, the reef. Pre-invasion reconnaissance saw it, but intelligence had underestimated how far it went and how shallow the water was. Larger landing ships, LSTs, built to carry tanks, ran aground, 400 yards from shore. Their ramps dropped into 4 feet of water, so tanks could not get off without drowning engines. The Higgins boats, drawing just 3 feet when loaded, skimmed over the reef with inches to spare. Coxswains reported feeling the hull scrape coral and hearing a sickening grinding sound, but the boats kept moving. Higgins had over-engineered the hull bottom, double-riveted seams and reinforced keel guards because he knew boats would hit things. That careful design saved the landing in the first 30 minutes. Second problem, the beach. The sand at Lunga Point was not the firm type from test ranges. It was loose volcanic material that shifted under weight. When the first boats hit at full speed, their bows dug in deeper than expected. Some buried 18 inches before momentum stopped. Crews panicked, thinking they were stuck. Then the ramp hydraulics kicked in. The weight of the dropping ramp helped level the boat and spread the mass. Troops ran off the boat, got lighter, and coxswains reversed the engines. Most got off in under 40 seconds. A few needed a second try, backing off at an angle to break suction. One boat commander later said he reversed, repositioned, and grounded 3 more times to unload later. Waves, the hull took the abuse without cracking. Third problem, enemy fire. This is where the simple design helped Japanese defenders targeted the boats with mortars and machine guns. Bullets went through the plywood sides. Higgins used plywood for the sides to save weight and steel only on the ramp and hull bottom. Troops crouched behind the ramp for protection, which worked because the quarter-inch steel could stop rifle rounds. The critical part, when hydraulic lines were cut by shrapnel, which happened to 11 boats in the first wave, crews switched to manual chains. 2 men cranking handles. The ramp dropped in 18 seconds instead of 6, but it still worked. That backup system, hydraulic first, manual, second, meant damaged boats kept running. Fourth problem, sustainment. Over the next 3 days, the 87 boats ran continuously. No maintenance facilities, no replacement parts, just crews doing field repairs between runs. They used seawater as coolant when fresh water ran out. They patched bullet holes with tar and canvas. One boat lost its entire hydraulic system. A mortar fragment destroyed the pump, and the crew ran it manually for 2 full days, 23 trips until a repair ship arrived. Higgins had designed every major part to be replaceable with hand tools and a brute force. Propeller damaged, carry a spare, and swap it in 20 minutes. Ramp hinge, crack bolt on a backup plate, and keep going. The after-action reports from Guadalcanal filled 3 binders. Navy maintenance teams checked every boat after the first week. They found stress fractures, worn bearings, corroded fittings, but no major structural failures. The average boat had grounded 31 times, taken multiple hits, operated in salt water without maintenance, and was still 87% mission capable. Engineers had predicted a 40% failure rate in the first 48 hours of combat. The actual failure rate was 9%, and most of those were boats hit directly by artillery. Guadalcanal did not just prove the Higgins boat worked. It proved that ugly, overbuilt, idiot-proof design beats fancy engineering when people are trying to kill you. Here is where the story gets crazy. In December 1941, Higgins Industries was a regional boat shop with 75 people building maybe a dozen boats per month. By December 1944, it was the largest private employer in Louisiana with over 20,000 workers. 7 plants covering 30 city blocks and delivering 700 boats every month. That is not just scaling production, that is industrial magic. And Andrew Higgins did it by breaking every manufacturing rule the government said was sacred. The military had very specific ideas about shipbuilding. You hire trained shipwrights who spent years learning the craft. You build boats one at a time, start to finish, with the same crew finishing each boat. You keep strict quality control with inspectors signing off at each stage. Higgins looked at that model and basically said, "That is cute, but we need 20,000 boats in 3 years, so watch this." He borrowed a trick from Henry Ford that the maritime industry considered heresy: assembly line production. Shipbuilders said boats do not move through factories. Higgins made them move anyway. He split LCVP construction into 14 major sub-assemblies. Station 1 made the bow, ramp, and hydraulics. Station 2 built hull sections. Station 3 handled engines and drive systems. Workers focused on one job, welding a specific seam, riveting a joint, wiring one electrical system. A kid from rural Louisiana who had never seen the ocean could learn to weld a perfect hull seam in 2 weeks. Traditional shipbuilders screamed, "This would make bad boats." Higgins invited Navy inspectors to test random boats off the line. The failure rate was 2.1% better than traditional shipyards, making one-off boats with master craftsmen. The workforce itself was. Revolutionary Higgins hired anyone who could hold tools. Women, black workers, Older men past draft age, even teenagers on summer break. In 1940s New Orleans, this was radical. The company integrated its factories years before the military integrated. Black and white workers shared the same assembly lines, ate in the same cafeterias, used the same bathrooms. Higgins' reasoning was simple. I don't care if they are purple with pink polka dots. Can they weld? But the social impact was big. By 1943, 18% of his workforce was black and 40% were women. Rosie the Riveter was not just a poster in New Orleans. She was building the boats that would win the war. The production tempo never stopped. In June 1944, the month of D-Day, Higgins Industries delivered 737 landing craft. That is 24 boats per day. One boat every 60 minutes, working 3 shifts around the clock. The plants never stopped. Welding arcs lit up the night sky like a continuous lightning storm. Workers clocked 60-hour weeks as normal, with 80-hour weeks common before major invasions. The company paid high wages, $20 per hour, when the national average was 65 cents, because Higgins understood that exhausted, broken workers build bad boats. Well-paid, motivated workers could keep quality while hitting crazy quotas. Raw materials became the limit, not labor. A single LCVP needed 1.2 tons of steel, plate, 80 feet of hydraulic line, 340 rivets, 15 gallons of marine paint, and one 225 horsepower gray marine diesel engine. Multiply that by 700 boats a month, and you need 840 tons of steel, 56,000 feet of hydraulics, 238,000 rivets every month on time. No exceptions. Higgins made direct deals with steel mills in Pittsburgh, rubber plants in Akron, and engine makers in Detroit. He bypassed military logistics when procurement officers were too slow, sometimes buying materials on the private market at higher cost just to keep deliveries on schedule. The Pentagon hated this cowboy style until they saw the boats arriving exactly when promised. By war's end, Higgins Industries had built 20,940 boats, not just LCVPS, but also larger LCMS-PT boats and special craft. That is more than all other American boat makers combined. The company made up 92% of the Navy's landing craft fleet. When Japan surrendered in August 1945, Higgins had orders for 12,000 more boats that were instantly canceled. Within 6 months, the workforce dropped from 20,000 to 800. The empire collapsed as fast as it had grown. But those 20,000 boats had already rewritten military history. Omaha Beach, 0630 hours, June 6, 1944, the most famous 6 hours in amphibious warfare history. And Higgins boats were the thread holding the entire invasion together. When you watch those grainy films or Hollywood recreations, you are seeing the result of everything: the design evolution, the manufacturing miracle, the combat testing, but also the blueprint that every amphibious assault for the next 80 years would follow down to today. The numbers from Normandy are huge in a way you do not fully get until you slow down and think about the logistics. The first assault waves used 1,089 Higgins boats across 5 beaches. At Omaha alone, 293 LCVPS made the run from transport ships to shore. Each boat made an average of 4.7 trips in the first 12 hours. That is 130 to 177 beach landings at one place in half a day. Imagine a boat grounding, unloading, and pulling out every 31 seconds during peak hours. The German defenders were not just fighting soldiers, they were fighting a mechanical system built to overwhelm them by repetition. Even when boats took direct hits, 34 were destroyed at Omaha by obstacles, mines, and artillery. The flow barely slowed because replacements kept coming. The rules that came from Normandy became the standard. Modern amphibious operations still follow the Higgins plan. Waves of landing craft, timed intervals, continuous resupply vehicles, landing directly on beaches. The U.S. Marine Corps current landing craft, air cushion, those hovercraft that look like science fiction, work the same way as an LCVP, faster, more advanced but same mission. Deliver troops and vehicles from ship to shore, then get out and do it again. The Chinese People's Liberation Army, Navy studied Normandy footage when making their Type 726 landing craft for possible Taiwan operations. The basic design has not changed: protected run-in bow ramp, quick exit. But here is what is often forgotten in the D-Day celebration. The Higgins boat's impact went far beyond Europe. In the Pacific, the island-hopping campaign was basically a Higgins boat conveyor belt over 5,000 miles Kwajalein. Saipan, Palelio, Iwo Jima, Okinawa. Each operation depended on those shallow draft workhorses running through coral reefs that would have stopped normal landing ships. At Iwo Jima, in February 1945, Marines landed 30,000 troops in the first 48 hours, using 482 Higgins boats on beaches, with loose volcanic ash so soft that vehicles sank to their axles. The boats adapted. Coxswains learned to hit the beach at higher speeds using momentum to climb above the worst sand. That ability to adjust technique depending on conditions came from the design's simple ideas. Andrew Higgins died in 1952, 7 years after the war ended, mostly forgotten and nearly broke. His company never switched successfully to peacetime production. Military contracts stopped, and he had used everything to meet wartime quotas, leaving no money for later. The man Eisenhower said won the war spent his last years fighting creditors. There is no Higgins Memorial on the National Mall, no aircraft carrier named after him. Most Americans have never heard his name, but if you have watched any beach landing footage from World War II, Korea, Vietnam, Gulf War, or Iraq, you have seen his work. Every ramp that drops onto sand comes from that swamp boat builder who convinced the Pentagon that ugly and practical beats fancy and useless. The modern U.S. military still uses landing craft that came from Higgins' design. The landing craft utility can trace back through 7 versions to the LCVP. When Marines hit the beach in training at Camp Pendleton or Quantico, they are using procedures written in 1943 based on Higgins' boat abilities. The plan assumes you can get troops and vehicles onto dangerous beaches in timed intervals. This was only possible because one engineer in New Orleans refused to believe it was impossible. Wars are won by tanks and planes and brave soldiers, but sometimes they are won by a swamp boat with a ramp on the front. Eisenhower knew that the rest of us should too.